Everything in this world is either mass or energy. For example, I am a human being. I have mass inside me. This is a screen. It is mass inside me. But what you are hearing from me is sound. Sound does not have mass. It has frequency. Hence, it is an energy. Well, if these two are the only things that we have in the universe, they might be somehow interrelated, right? Well, to answer that question, we have E equals mc squared. So this E equals mc squared equation was made by a 15-year-old boy who dreamed of chasing the speed of light. And later, in 1905, he discovered E equals mc squared, and that was none other than the great scientist Albert Einstein. Well, before 1900s, energy and mass were known by people as two different complete things. But after the discovery of E equals mc squared, they were related, and Einstein proved to the world that energy can be converted into mass, and mass can be transformed into energy if there is suitable conditions to do that. Well, to know first about E equals mc squared, we need to know about the general things, or let's say general terms, that I used here. So, does anybody know what this E stands for? Yes? And M? And that is mass, that's correct. And C? The speed of light, that's correct. So E is energy, M is mass, and C is the speed of light. To get to know about this, let's take a very simple atom, which is the helium atom. As you can see this is the electrons and neutrons and protons, which are making the nucleus of the atom. Well, the fun fact about this atom is, if we see the mass of the whole atom and add the mass of neutron and proton, which actually makes the mass, they are different. They're not the same. The mass of neutron and proton summed up is more than the mass of the whole helium atom. How is that possible? Anybody has an answer to this? Okay, let me answer this question. So, as you can see in the picture, neutron and proton are binded. And, of course, they need some force, or let's say binding force, to be binded and sit there as the nucleus of the atom. And the binding force is used as the mass of neutron and proton. So hence, if we just add the mass of these two, we get more than the actual atom has its own mass. Well, after the discovery of E equals mc squared, the definition of mass had changed. Before 1905, people used to think that mass is just the total amount of matter contained in a body, which was not true, and after E equals mc squared was discovered, mass was known and seen in a completely different matter. Mass was known as a condensed form of energy. That means mass was made up of energy. And this is the exact definition we're reading now. To get this bit more simplified and to let everybody here know, let me ask you a question. We have two balls, two basketballs here. One is at rest, and one is moving in a very high speed compared to the velocity of light. Which of the basketball has more mass? Any answers? The ball which is moving in a very high speed compared to the ball which is moving in a very high speed compared to the velocity of light has more mass. How is that possible? Any answers? Yes.
Because the ball moving at a high speed more potential energy than the ball at rest?
Well, that's not completely the answer, but that's somehow right. Yes. Yes. Now let me give you the answer to this question. The answer to this question is because the ball which is moving in a very high speed has kinetic energy, and the kinetic energy adds up as its extra mass, giving extra mass to the ball which is in a very high speed compared to the speed of light. And if we have accurate measurements and the instruments which is needed, we can clearly see that this ball is moving in a very high speed compared to the very high speed compared to the velocity of light has more mass. And this answer is given by expressions E equals mc squared. Well, further simplified, there is things like m naught, which is quite complicated, so let's not go in that form. But this is the expression that gives an answer to that phenomena. Now, I have a stone here. Let's drop the stone in the ground. Now, let me question you. I had my stone in my hand. Let's take that as the first event. And the second event, the stone dropped. When did the stone had more mass? When I was holding it or when I let it go and sound was produced? Any answers? Yes?
When you let it go and sound is produced.
Any explanations?
Since there's kinetic energy that it adds up.
Well, that's not completely the answer, but it's somehow right. Well, the answer to this question is, when I was holding the stone, it has its own mass. But when I dropped it, sound was produced, right? So where did that sound come from? It should be coming from somewhere. Yes, and that sound was formed when the stone lost its mass. So that's exactly what E equals mc squared is trying to say. When I drop the stone, sound is produced. So what E equals mc squared says here is, how much mass is lost when I produce that amount of sound? And so now this was the mass part of E equals mc squared. Let's get to know about the energy part. Let's take an example. Any object you see, but for me, I'm taking this as chair. What is chair made up of? Matter or it has frequency? Any answers? Yes? Yes. Chair has mass and it has mass. So, according to what I said earlier, mass should be completely turned into energy. It can be transformed into energy, and energy should also be can also be transferred into mass. Now let's take an example of this chair. This chair is mass, right? If it has mass, then I want it completely turned into energy. And if I completely turn it into energy, that means vanish, because we can't actually see energy, right? Can you see my sounds floating around this room? No, you cannot. So if I want this chair to completely vanish, or let's say completely turn into energy, how much energy can be produced? And this is exactly what E equals mc squared says. And this is the beauty of E equals mc squared. Thank you.